Good afternoon. This is Mr. Hoopert speaking, as always. Alright, the manager of a coffee shop needs to hire 2 employees, 1 to work at the counter and 1 to work at the drive-thru window. Katie, Bob, and Alicia all applied for the job. How many possible ways can the managers place them? So here's what we have. We have a counter person. This is a counter. And then we have the drive-thru. Alright. Katie could get hired at the counter. But then that would mean Bob or Alicia could be the drive-thru person. Well, what if Bob was at the counter? Alright, well then if Bob's at the counter, either Katie or Alicia could be at the drive-thru. And then what is the other option? Bob, Katie, I need Alicia at the counter. So I'm kind of making those go to Alicia, so this could be Katie at the drive-thru or Bob. So when I look at this, I know I kind of screwed this order up, but there is 6 different combinations of workers. Now, I can use permutations to determine the number of outcomes for a given situation. So what we're going to do is, we just talked about this. The different orders and the different combinations is what makes this interesting. Alright, so we're going to call these permutations when the order matters. Meaning, you can't just hire 2 employees. Alright, you got to give them a title. And that title is either the counter or the drive-thru. Alright, so that's why it's important. If you look at Alicia here, there's actually 2 combinations for her getting hired. Because they're combinations. They are either Katie or Bob. So there's a little bit more in depth when it comes to probability, and so we're going to show you those examples today. So a permutation is an arrangement of objects in which the order is important. Order is important. Remember, AB is different from BA, and I just showed you that. Alright, Bob and Katie are not the same person, so that arrangement is different. So how many different arrangements are there of the letters in the word triangle? Well, first off, I need 1, 2, 3, 4, 5, 6, 7, 8. Alright, so there's 8 different arrangements. So, I would have did 8 factorial. Right, how many different arrangements are there? Well, 8 first, then 7, then 6, and 5. Alright, this is just going to go down all the way to 8 factorial. Well, good, I can do 8 factorial in my calculator still. And we can get there to be 40,320 ways to arrange those letters. So, there's a lot of ways to arrange those letters in the word triangle. How many different arrangements are there of the letters in which the word triangle, if the first letter is A? So, if my first letter is A, it has to be A. What can my second letter be? Well, if I only have 8 letters, I already used A. That means there's 7 left. Then there's 6 left. And then there's 5 left. So the answer to this actually becomes A, which is 1, really, 1 way, times 7 factorial. And then 7 factorial is only 55,040 ways. So, by just removing 1 letter, look at this, 8 factorial is 40,000, 1 letter is down to 5,000. Alright, so you have to understand, hey, the order and stuff of arrangements is pretty big. So in Minnesota, license plates are made up of 6 characters, 3 letters, and 3 numbers. So 3 letters. So I have letter, letter, letter. Letter, letter, letter. Alright, there's 26, 26, 26. They don't change. Alright, then we have numbers. So number, number, number. One thing to note is on your calculator, if you look at it, there's only 10 numbers. Because with a 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, you can create all the letter or all the number combinations in the world. That's why you only have those 10 numbers. Alright, so what I would do with this is I'd just multiply them. 26 times 26 times 26 times 10 times 10 times 10. So I'm going to get 175,760,000 ways for a Minnesota license plate. Now, for some of you who don't trust me, I do make mistakes on purpose, but this time I did not. I did letter, 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 and then number, 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 because in the state of Minnesota, you can have this combination, or you can have what the picture has down there, which is number, 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 letter, 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 because that is a different combination as well. So then guess what? This is 10, 10, 10, and 26, 26, 26. Well, I know you're not all baby geniuses, but that is going to equal the same thing. So really what I could have done is just multiplied my first answer by 2. Because in the state of Minnesota, the total is going to be a combination of 35,152,000 different ways. So if we have that many combination of people in Minnesota, they might run out of it eventually if they have 35 million people here, but we don't have quite that many yet. So we should be good on the different combinations of license plates. So there are a ton of ways to make a different combinations. So permutation, what that means is N is our total number of objects. Right? Number, N stands for number a lot. R is the number of objects you are using. So like that last one, where in the last notes video at the end we did 12 different rides, but we only had time for 8 of them. Right? In that one, we would have had 12p, and then we only had time for 8 of them. So then I think we would have had 12 factorial over 12 minus 8. And if you look at your notes 1, we probably had something like 12 divided by 4. Alright? So I know that's what we had at the bottom of notes 1, so that's what we were doing. We were actually already starting permutations on you in the bottom of notes 1 videos, because those are important. So order is going to matter, remember. So let's evaluate a few of these. So like I showed you with the 12, you are going to want to write 5 factorial over 5 minus 3. And I like to keep the parentheses. It'll always be a positive number in there, otherwise you did something wrong. It might be 0 sometimes, but that's just 1. We'll talk about that. So 5 factorial divided by 2 factorial. Now one thing though is 5 times 4 times 3 times 2 times 1 over 2 times 1. You should know these 2 times 1, those go to 1. So what we really have left is just 5 times 4 times 3, which is a grand total of 60. So that's what I would have had for that one. When I do 7, 2, 7 factorial over 7 minus 2 factorial, you're going to get 7 factorial over 5 factorial. So like I did before, 7 times 6 times 5 times 4 times 3 times 2 times 1. If you want to do some reducing before you multiply out, that's a good idea, because instead of typing 7 exclamation point in your calculator, hitting enter, you could just do 7 times 6, which is 42 ways. Right? So if you like reducing them before you multiply, you're going to have to know how to do that, so I would start doing that a little bit. Otherwise, you could have had 7 probability. This would have been 5040. So let's come back to this. This would have been 5040 divided by 120. And I bet you still get 42 ways. So however you want to do it, if you're dependent on your calculator, know how to use it correctly. Otherwise, you can just use some common algebra and reduce the denominator and denominator. So here's our formula. Now let's talk about this. There are 10 finalists. So this is going to be my N in a figure skating competition. How many ways can gold, silver, and bronze medals be recorded? That is awarded, not recorded. That's 3 ways. Is gold different than silver? Yes. So the order here is very specific. So what I would want is 10 factorial over 10 minus 3. When I look at this, I would see 10 times 9 times 8 times 7 factorial. Because I know that it's just going to keep going on. 7, 6, 5, 4, 3, 2, 1. All right, I'll just write it. So times 6 times 5 times 4 times 3 times 2 times 1. All over 7 factorial. So notice what I did here is 10 like this is going to be 7 factorial, which leads to this one, times 5 times 4 times 3 times 2 times 1. Right, all this stuff, 7 divided by 7 is 1. 6 divided by 6 is 1. 5 divided by 5. 4 divided by 4. All these reduce to just 1 over 1. Well, 1 times 8, or 1 divided by 8, doesn't change the value of it, so you're just going to have 720 ways. Right? 8 times 9 is 72, times 10 is going to be 720 ways. One other thing you might start seeing me doing is, instead of what I was going to do, is I was going to write 10 times 9 times 8 times 7 factorial divided by 7 factorial. These two things right here are going to cancel to be 1 every time. So I might start writing it in the way in blue. So a newspaper has 9 reporters available to cover 4 different stories. So R is your 4, and is the 9, because that's the total. So I would have had 9 factorial over 9 minus 4 factorial. That's going to equal 9 factorial over 5 factorial. And what I would start doing is I would start suggesting 9 times 8 times 7 times 6. All the way, the rest of the way down is 5 factorial. But if I'm dividing by 5 factorial, what can I do with these two values? They're going to be the same thing, so they're going to reduce to 1. Well, I don't need to write ones because we're lazy mathematicians. 9 times 8 times 7 times 6. This is going to be 72 times 42. And I don't know that off the top of my head, surprisingly or not. But 3,024 ways they can choose to cover the reporter. I don't know what that thing in the bottom right is, but thanks, Miss Johnson, for putting it on the PowerPoint slide to add presentation. Moving on. Espanol. So that must be Miss Brisky. I wonder if she was a teacher here one time. Huh. Ask pairs of students to read statements in Spanish and then translate them into English. If Miss Brisky chooses pairs, 1, 2, 3, 4, 5. So I see 5 students, so that's my in, and I want pairs, which is 2. How many different ways can she pair students? I would have did 5 factorial over 3 factorial. Look at that. 5 minus 2. I'm skipping a step. Right? You guys should catch on to this stuff. Right? You should know 5 times 4 times 3 factorial over 3 factorial. These reduce to 1. So 5 times 4 is 20 ways she can pair the students. So just 5 kids in class, and she can pair them in 20 different ways. It's actually kind of amazing. Now, permutations with repetitions. The permutation of M objects where P and Q are alike is, boom, N factorial divided by P factorial, Q factorial. Don't worry about this. I'm going to show you. It's more like fundamental counting principle, but then you divide by things that you know. So how many ways can the letters in the word Mississippi be arranged? First things first, how many letters are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there are 11 words being used, so that's your in. Now, what I would do is I see 1, 2, 3, 4. So there's 4. I was going to put an equal sign. There's 4 S's. S's. There is 1, 2, 3, 4 P's. And looks like 2 P's. Excuse me. This is 4 I's. So what we would do as we go 11 factorial divided by 4 factorial, 4 factorial, 2 factorial. So that's what it means when it says P and Q divided by the N. So they repeated in those letters, so that's why you divide by the number of letters. This is the most common mistake on the quiz. People forget to look at these two S's and say, hey, I need to divide this by 2 factorial. Now, what I would have done is I probably would have did 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 factorial. Then I would have divided it by a 4 factorial. Then I probably would have went 4 times 3 times 2 times 1. And then I would have did 2 times 1. So what you should see a little bit is my 4 factorials cancel. Now the reason I wrote the rest of them out is because my other numbers aren't big enough. However, I could look at 3 and 2 here. 3 times 2 is 6. So I can actually cancel those out. What about if I square the 4 and square the 2? 4 and 2 is 8. So now I can cancel the 8 out. So what I really have for the number of ways I can spell Mississippi is 11 times 10 times 9 times 7 times 5. When you do something like that, you get 34,650 ways to arrange the letters in Mississippi. Right? So, hey, look at this stuff. This stuff's pretty important. When we have multiple factorials to divide by, you can rearrange them and make them common multiples. 3 and 2 together are 6. That's why those are canceling there. If you don't understand those red circles, come ask, please. How many ways can the letters in the word geometry be arranged? Okay, first off, I only see 3, 4, 5, 6, 7, 8. 8 letters, so N equals 8. And the only letters I see that repeat are E, so I would have just said 2 E's. So I would have just did 8 factorial over 2 factorial. Well, guess what? I would have typed 8 factorial in my calculator here. Because 8 factorial is actually 4,320. Good news for you. 2 times 1 is 2. So I would have left the 40,000 in my calculator, and I would have just hit divide by 2. So that's 20,160 ways. And last but not least, Schoolology quiz. We're not doing it. Thank you for listening. It has been a wonderful evening. If you're getting questions or you're confused with the calculator work, you need to come ask. Thank you very much. Have a nice day. I don't know how to